Welcome to Study Loop.
So in this question, we have a light ray entering a glass slab at point A at 45 degrees and undergoing a total internal reflection at point B. And they want to know what is the minimum value of index refraction from this information alone. So let's call the angle of incidence in the second surface here theta incidence. And the condition for a total internal reflection is that n sine of theta of incidence greater or larger than 1. We want to find the smallest value of the index refraction n for which this inequality holds. We can use the law of refraction in the first surface to find the relation of the initial angle of angle of incidence with the theta 1. So in the point A, we get that n sine of theta refracted is equal to sine of theta 1. And the angle of incidence is the complementary angle of the refraction. So theta of incidence is 90 degrees minus theta refracted. So we can use this relation here in the inequality. So let's do this. So you get that 1 must be smaller or greater than n sine of 90 degrees minus theta refracted. This is equal to n cosine of theta refracted. And we can square both sides and get that 1 must be greater or equal to n square cosine square theta refracted, that we can write as n square 1 minus sine square theta 2 of theta refracted. Now we can substitute the relation between the refracted and the incidence angle. So this is incidence. And we have that this is n square 1 minus sine square of theta divided by n square. This is n square minus sine square of theta. And we want to find the smallest value of n for which this equation holds. So this is the smallest value will be when it will be inequality. So let's find what value is this. So the smallest value will be when this is saturated, sine square of theta. So we can solve for n. N is equal to the square root, only picking the positive square root, 1 plus sine square of theta. And this is square root of 1 plus sine square of 45 degrees. This is 1.22. So this is the minimal index refraction for the glass, given the initial angle that we get.